DHCP is great for computers on a network because it means you don't actually have to configure an IP address on a computer. Instead, you just plug it into the network and it'll get its IP address from the DHCP server. But if you combine it with Dynamic DNS, it means you don't even need to know what the IP address is for that computer. You can just refer to it by its fully qualified domain name instead, and the DHCP server will keep that updated on the DNS server for you. It's all automated, the whole process. But how do you actually configure Dynamic DNS on an Ubuntu server, for example, and actually configure the DHCP server to take advantage of all this? Well, if that's something you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now I'm going to put a timeline in the video in case there's a particular section that you want to jump straight to. But I'm making an assumption that you've already got DNS and DHCP already installed. If not, then you can refer to some previous videos that I did on how to install these. Now I don't want just any computer being able to make DNS updates. So for that reason I want to introduce a secret password that only certain computers know about. Or more specifically, I want to give each individual computer its own unique password. That way, if one computer gets compromised, it doesn't affect everybody. I only have to go around to that specific machine and update DNS on that specific machine with a new password, rather than going around every single machine and updating them with a new password. It's kind of like similar to usernames and passwords. Every user gets their own unique username and password. It always limits the fallout if there's ever a problem. So here on the DNS server, I'm going to switch over to /etc/bind, which is where DNS is. And I'm going to run this command ddns-confgen. Now, what it does, it actually creates output that we could use, because we've got a name here that we can reference. So this is the name of a key, but this is the password that we can use for our authentication. Now there's different ways you can use it. You could just basically paste this into the config file, but the only trouble is if you need to provide that config file to a third party, for example, as part of some troubleshooting process, the password's going to be included and we don't want that. The whole idea is keep this information as secure as possible, so we don't want this in the config file. So for that reason, we're actually going to create key files, individual key files for each individual computer, and then we'll reference those within the actual config of either DNS or DHCP. So by default, we're getting this key name of ddns-key. Like I was saying, we want to give each individual computer their own key, so we've got to change that. That's got to be unique to, whatever computer is going to be using it. So what I could do is I could just literally take that configuration sample there, and I could just change that within the the editor that I'm using, or I could run the command again and I could actually specify the name that I want to give this key. So for example, if I use the fully qualified domain name for this DHCP server, for example, you'll see the key name changed. I mean, another thing to point out is the actual password has changed as well. So it's every time you run the command, the password changes. But yeah, different ways you can do this, entirely up to you. But I'm just going to take a copy of that, and then I'm going to use sudo nano. We'll call this one DHCP1.key. And I'm going to paste the contents into there. And then I'm going to save that file. And if you look at our folder, we've now got a file called dhcp1.key. Now, the permissions that are set up are read-write for root, which is fine, and read for bind, which is great because the the DNS service, I should say, will only be able to read that key file. And the idea is we'll need to update the configuration of DNS to reference this key file along with the actual name of the key. Hence why I'm trying to keep things unique, so that when I tell the DNS server the permissions for the DHCP server, for example, I can refer to its own specific key. So now that we've actually got a key, it's a case of we need to actually update DNS. Now when you install the DNS service onto a Linux computer like this, you'll find that the configuration files and some zone files that come with the service get installed into the /etc/bind folder. Now, not surprisingly, therefore, my forward lookup zone and my reverse lookup zone are in this folder as well. Now, what some people do is like create a subfolder within here called zones, for instance, if they're going to look after multiple zones. But entirely up to you. The only trouble is, well, if you're going to introduce dynamic DNS, you won't have write access to this folder, or more specifically, the bind service won't. Now, when the DHCP server sends updates across to the DNS server, DNS will need to be able to update my forward lookup zone and my actual reverse lookup zone, but it doesn't have write permission, so it can't do that. It also needs to create what are called journal files. So these are completely new files that align with the actual zone file for it to keep track of changes. But again, it doesn't have permission to do that. So that's a bit of a problem. You could, for instance, think, well, let's change the permissions on the bind folder. The only trouble is that you're kind of compromising the security, because now you're giving permission for DNS to your configuration files. And the whole reason this was set up was to prevent that in the first place. The whole idea is the bind service is running as a non-root account, so it can't make changes to your config files or your static zone files that we've got here. And I refer to these as static zone files, in that typically if I build a server, give it a static IP address, I then come back to the DNS server and manually update the zone files so they remain static. Bind doesn't change them, I do. Another problem you would run into, even if you did change the permissions, is in the case of distros that are based on Debian, for example, there's a security module runs in the background called AppArmor, and that'll prevent any of the changes if you try to stay within this folder as well. So for that reason, we actually have to move our zone files. Now, in my case, I've only got one zone, so it doesn't really matter. But the folder actually already exists. If I do ls-l/var/lib, you'll see there's a folder up near the top here called bind. Now, that was set up, the permissions were set up for the group bind to have read-write access. So the idea is, if you're going to have dynamic zones, so these are zone files that dynamic DNS will be updating, then you need to move them to that /var/lib/bind folder. Anything that's just going to stay static stays within this folder. Now again, I've only got one zone anyway, so even though I am maintaining this myself, I still have to move the files to that other folder, otherwise the bind service won't have access to them. So we're going to do sudo move, I'll give it the name of that file, and I'm going to move it to /var/lib/bind, and then I'll do the same with this one here. So that's my reverse lookup zone. And I'll just double check that that has moved the files where they need to be. So our two files now exist over there, and they've gone from here. The only problem is, if we have a look at our configuration file, you'll see that the configuration for DNS is pointing to the old location. So we actually now have to update the configuration of DNS. Now, to turn this DNS server into a dynamic DNS server so that it accepts updates from our DHCP server, for instance, we need to edit its configuration. Specifically, we need to edit the named.conf.local file. So first thing I'm actually going to do is just take a backup copy of that file, just so I've got something to refer back to. And next we're actually going to edit that file. Now I need to include the actual key file that we created earlier. So I'm just going to take a copy of this line just to save me typing it out. So basically we're telling it to include this specific file into the config. Essentially it's the same as if we'd actually pasted the entire contents in here anyway. When the actual service just reads the file, it's going to include the contents as part of the process. But the good thing is that there's no password referenced in here. If anybody were to read the actual configuration file, you don't see that password. The system can see it because it includes the actual separate key file that we've created. But if we have to send this off, for troubleshooting purposes, whoever reads it can't see it. So that's a bit of a better security approach by having the keys separate to the actual config file. Now the next thing I need to do is to actually change the location, because they're no longer, the files themselves are no longer here. So I need to point them to where they need to be looking. So yeah, that's where they need to go. I can just change this slash it separate apart. So that's now referring to the correct locations. Now, the next thing to do is to actually enable the dynamic DNS part of it. Now, I'm just going to actually copy and paste in a policy that I've created as an example. I don't want that going there. I want it going there. And I'll just take that line out. I'll change that one to that. Just checking against what I've already got. So the idea is there's different ways you can do this. There's a different command you can use, but this gives you more granular control over what computers can do, basically. So what we've got is a command which is update-policy. Then within there we've got a series of policies, basically, that say what that specific computer can actually do, or at least anybody who's got the key, I should say, not necessarily the computer. But the way I'm thinking is that each computer gets its own key, hence why I refer to it, what a specific computer can do. But up here we've referenced the file to include the specific key for the DHCP1 server. And then here we're actually making a reference to that key as we've called it. Because if you go into that file, dhcp1.key, there's an entry of a key called dhcp1.templab.lan, which is the fully qualified domain name for that server. It doesn't actually have to be. This is just for me to give everything its own unique reference. So when you set up that grant command up here, we give it the name of the key, and then we've got to put in further information as to what it's going to do. So in my case, it's a DHCP server, which means essentially it needs to be able to update any host effectively within the domain. So that's why I'm using this wildcard option. And it then allows me to put in *. And then the name of my domain name, for example, or more specifically the zone that we're dealing with. So it's effectively saying you can update records, any record within templab.lan. But I'm being very restrictive in terms of which records. So I'm only going to allow it to update a record. So they are the host records for IP version 4. And there's also these DHCID records that the DHCP server actually creates because it stores information within DNS. So whenever you want to do this specifically for Linux computers, you'll find you need to allow it to update two specific records, the host record and the DHCP ID record. It says DHCID, but it's a DHCP ID record. So it's very restrictive in the sense that it won't be able to update, say, like MX records for email servers, or the NS records, which are for the domain name server records, for example. It can only reference and change those specific types of records. So I do have some, clear restrictions. Now, if I wanted to actually set up specific computers to do specific updates, so for example, let's say I had a certain server that I wanted to be able to do its own DNS updates, I could be more restrictive and only allow it to update its own DNS record, for example, in its own type A record and so on. There's a lot of different restrictions. I'm not going to go into too much detail here. I just want to show you how to set it up specifically for DHCP because it makes life a lot easier going forward. Now for the reverse lookup zone, it's pretty much the same, except in this case, we're talking about pointer records. We don't have the same DHCID record. It's just specifically that pointer record that it needs to update. Otherwise, the policy is the same. So I'm just going to save my config changes here. And next thing I want to do is I just want to run one final command, which is basically it's just a name check command. So if we run this command, sudo named.checkconf, what it does is essentially it's just running a sort of like a parser to check the syntax of that configuration file, just to make sure there's nothing wrong in what I've typed in. In my case, I copied it and pasted it anyway. But then what we're going to do, we need to actually reboot the DNS service, not the server, just the actual Bind9 service. So that's sudo systemctl restart and then Bind9, which is the service. And then what I can do is check and see if it's reporting any errors by running the status option instead. So it hasn't reported any issues. So that's a good thing. So now that we've got this up and running, the next thing I need to do is to actually update the DHCP server to actually take advantage of this. Now I need to update the DHCP server so that whenever that actual computer either leases an IP address or releases one, it'll go and tell the actual DNS server that we've got configured here. But it won't be able to do that unless it actually has the key. So we're going to have to take a look at this key that we've created, because for me, the two actual services are running on two different computers. I can't copy that file, say, from this computer to that computer because I'm running UFW, which restricts which computers can get remote access. If you're running this on the same server, so you've got DNS and DHCP on the same server, you can just copy it from one folder to another. But for me, I'm just going to take a copy of the actual file into the clipboard, jump across to my DHCP server, and I'm going to create a new file on this server here. Actually, I can't get access to that yet, so I'm just going to go into the actual DHCP folder, and then I'm going to use sudo to be able to do this. So sudo ddns keys dhcp1.key. So the difference between my DNS server and my DHCP server is that DHCP server is actually running as root. So that's why I'm having to use a sudo command to create the file. So I'll just paste the contents from the clipboard. So now both computers have got the same key. So the next thing I need to do is update the configuration file. So that's the dhcpd.conf file. So we're going to take a copy of that first. And then we'll edit that. So again, I need to actually include the DNS key here into this configuration, otherwise it won't know anything about the key. So again, I'm going to save myself a bit of time, and I'm just going to copy the line that I've already created. I'll paste that into there. So as with DNS, what's going to then happen is when this file gets read, it's going to include the contents of that file. We won't be including a password within the configuration file. So again, if something goes wrong, we need to get somebody else, like a third party, to troubleshoot this file. We can give them the config file, but they won't know what our password is. Now, the next thing we need to do is to actually update DDNS, because the actual system on the DHCP server here isn't actually taking advantage of that. So I need to enable that option here. And I also need to change the style. Now there are different styles. If you go out on the internet, you might find some people use interim as the style, but that's been actually deprecated. So we've introduced our key. We've introduced, or rather turned on, DDNS updates, and we've changed the style. Next thing we need to do is to actually introduce these zones. So I'm just going to copy these lines that I've already created. And I'm going to paste this in, and I'll explain what they're for. So this is my forward lookup zone, so zone templab.lan. I'm telling it to go and talk to the primary DNS server, because that's what how DNS works. There's a primary and there's various standbys. So there's only, at any one point, there's really only one server that's in control of the database effectively. And in my case, that's its IP address. And then on the next line, I'm actually referencing the key. So again, we've included the contents of our dhcp1.key up here. Within there, there's a key called dhcp1.templab.lan. The fact that it's the FQDN, the fully qualified domain name of this computer, isn't relevant. This is just the reference that I've used within that file, so that when DHCP comes along and reads this actual file, it's going to basically look for an entry called dhcp1.templab.lan in what's included here. It's got nothing to do with the fact that it happens to be the fully qualified domain name. It's just the way I've set the referencing up. And then for the next zone, I've got to put in, which is the reverse lookup zone. I've got to tell it what the zone file is. And again, we've got to tell it what our primary DNS server is and tell it what the key is. One thing to point out is I am using dots at the end of these. With DNS, I didn't have to bother putting them in. With the DHCP server, I do have to put that dot in at the end. It's kind of like with DNS, dot is the root, effectively the top of any domain. It all starts at dot and you work your way downwards from that. So now that I've put those in, I will save my configuration. Next thing I need to do is restart the DHCP service. So systemctl restart and then ISC-DHCP server. So that's the name of this particular DHCP server. And then we'll go and check what the status is. See if it's made any complaints. Okay, so no real complaints have come back there. So now that we've actually done that, we've configured our DNS server, we've configured our DHCP server. So the next thing to do is test and see if it actually works. So I've got a server here called test1, and at the moment it's not actually operational. So if I go over to my DHCP server and ask for an actual list of IP addresses that have been leased, at the moment it's empty. So we'll jump back to our DHCP server. I'll just minimize this screen so you can see the ESXi server, and we'll turn this computer on. Now this computer is actually set up for DHCP, so once it boots up, it'll go off and it'll talk to the actual DHCP server and it'll ask for an IP address. What should then happen is the DHCP server, it'll go and tell the DNS server, and as long as the DNS server is allowing that update to take place, it'll go off and update the actual host entry files for that server. So we'll jump back to here and just see if that IP address was leased out. So we've now got a lease. So if we go over to our DNS server, we do ls/var/lib/bind. I'll put a -l in there. So you can see we've now actually got a journal entry file, and what it should have done then, eventually it'll catch up, it'll start to update the actual zone files. So I'll just open up another window here. If I do host 172, I want to do the forward lookup zone, so test.temp lab.lan. There we go. So you can see it has actually updated that entry. So we don't actually see anything at the minute, and that's just because it takes a while. I mean, if I do more db.temp lab.lan, would help if I actually reference the proper file. So we don't actually see that as a test server in there. And it's just, as I say, it's just going to take a while. But eventually what we'll get is an actual entry within here that actually shows a record for that specific server. We're not seeing a reference yet for the pointer, which is interesting. If I go back to here, if I actually ask it for the reverse, so 172.16.19.229, yeah, it's coming back and saying it's not found. And if you notice, there is no journal file. You can't actually read anything from the actual journal file. To you or I, it doesn't really make much sense. There's some reference in there for a host name, but that's not always actually seen. So for some reason, it hasn't actually updated the reverse lookup zone. So what we'll do is, this is if you're going to be doing any troubleshooting. I'm going to basically monitor the system log file to find out what's going on here, because there's clearly something not quite working. So first thing I'm going to do is just double check the config for bind. So Yep, so it's allowing, it's granting permission. So /var/lib /bind/db172.16. Okay, so the DHCP server. (16.172) in_addr.arpa. Okay, so that's fine. So I'm just going to paste this command in here. Now, basically, that's just going to monitor the system log. I'll get various errors complaining about the hard drive with this being on a virtual machine. But what I'll do is I'll reboot this ESXi computer that I've got running here, or more specifically just the virtual machine within it. And we should get some sort of feedback to say what the problem is. So it's saying there how it deleted some records. So it deleted an A record, then a DHCID record. So once that computer boots back up again, there we go. So there's a reference there. So I'll just stop. So it's saying there that it's actually rejected the reverse pointer for some reason. There's something it doesn't like. So if I go back to my configs, just make sure I've done this properly, because there's obviously something in those that it does not like at all. Whatever if I could spell or type. Right, so that's right. I made a mistake when I actually created this configuration file. The cursor was in the wrong place. So it's a good thing I actually ran into this problem, to be honest. But I actually pasted that part in here, and then I pasted it up in the correct place. And then when I fixed it, I only updated the pointer record. I should have actually updated the zone as well. So this should be star dot. So it's the name of the actual zone. So that's why it's failing, basically. I was allowing it to update pointer records in the forward lookup zone when I should be giving it access to the reverse lookup zone, because that's what the reference is up here. This is the reverse lookup zone we're telling it about, and so I should be granting it permissions in the actual reverse lookup zone. So I'll save that change. CTL. Well, actually, I'll do a name check first. Okay, no syntax errors reported. So sudo system CTL restart, and this is Bind9. And then we'll ask for the status just to see there's no issues. Okay, so I'll go back to my test computer again. Actually, what we'll do is we'll run that tail command again. So basically, that's just constantly monitoring the syslog file. So we'll come back to our computer and I'll tell it to reboot. Come back to our DNS server. So again, it's deleting the resource records. That's what the RR bit's for. So it's saying it's deleting a resource record of type A and then a DHCID one. And that's the reason, if you're curious as to how I know which records to allow, it's because I was monitoring this. So this time round, I'll just cancel. So this time round, the computer's rebooted. It's asked for an IP address of the DHCP server, and DHCP server's updated an A record, a DHCID record in the forward lookup zone. It's done a delete and then an actual new update for the pointer that goes in the reverse lookup zone. So if we do ls/var, well, do a -l again. So you'll see this time we do actually have a journal file. So that's something you can reference, is the fact that, right, it's actually made a change. Now it still hasn't gotten around to updating the reverse lookup zone because we're still on root and bind, root as the user, bind as the group. But you'll notice the forward lookup zone has changed to root, it's changed from root as the user to bind as the user. So if we do have a quick peek at that, sudo or /var/ db.temp. It's actually created, it does create quite a few changes, which is interesting, but you'll see it's stuck in a TTL entry, and we've got a test one entry. So this is our host test one. This is the A record that goes with it. This is the DHCID record that goes with it. And it's made another change further down because the DHCP server is only allowing these for about 300 seconds versus like a long time that I put in. Well, it's 5 minutes. 1 week is what I'd originally set DNS up as. It's put that extra entry down there because it's obviously doing these, by the looks of it, in alphabetical order, which is interesting. Anyway, if we go back to there, it still hasn't changed the reverse, but at some point it will. But if we do a host update, so when I say a host update, I'm just going to the DNS server and asking it for a host entry for test1.templab.lan. I'll ask it for one for the reverse. Now this time, you see, before it was coming back and giving us a response of 3 saying it didn't know. This time it's coming back and saying, right, that IP address belongs to, and there's your host name. So what this basically means for me is that I can now spin up any computer I like within my environment, my test lab that I'm running. Doesn't matter what subnet it is, because this particular computer, the DNS server that I've got running, it's set up for all of the various subnets that I've got. Any computer will go and talk to the DHCP server to get an IP address, and then the DHCP server will then go and tell the DNS server. And it means that going forward, I don't really need to know what the IP addresses are of those computers. I just need to reference them by the host name. So as long as I actually make sure that every computer gets a unique host name, then the DNS server will be getting unique entries, and it means, I don't really care what IP address gets allocated from a DHCP server. I just need to know, well, what host name did I give it? If it changes somewhere down the line, which it can, usually whenever you restart a computer, as long as it's fairly regular, then it's not too bad. Whereas if a computer's been offline for quite a while, that IP address gets lost, and it might have been allocated out to a different computer. So when that computer comes back online, it ends up with a completely different IP address. But again, for me, it doesn't really matter. I've just got to reference them by the host name now going forward. Well, now that we've got a dynamic DNS server, we've got to think about maintenance going forward. We didn't have to worry about that so much before because this was just a static environment. I mean, we've got a forward lookup zone here, db.templab.lan, for example, and we've got our reverse lookup zone, db.172.16. Now, an administrator would have been looking after these two files, but that's it. The challenge we've now got is that we've also got the bind service maintaining these files. So there's a bit of a conflict going on where you've got two entities potentially could be altering a file at the same time, and that causes a bit of a clash. And this is a database system, and you can't really have two entities trying to make a change at the same time. So in my particular case, or if like me, you've got a zone file that contains static entries, but also it's going to have dynamic entries, you actually have to disable the system, basically, this dynamic update, to stop the actual bind service making changes when you want to make changes. So to do that, what we do is run a command, which is the rndc command. We'll say sudo rndc freeze. And that basically just blocks out any dynamic updates effectively. If a DHCP server, for example, that we've got here, tries to send any dynamic updates now, they'll actually get refused. So that's something you need to bear in mind. If you're doing this within a company, for instance, you'll want to be doing it outside of hours when there's less likely to be any dynamic updates taking place. So something to bear in mind is you're actually locking the system out. I mean, eventually it'll catch up, but yeah, it's best done when there's likely to be fewer changes actually taking place within that dynamic environment. But the next thing we need to do is to then edit our file. So we go to sudo /var/lib /bind/db templab.lan. So if I edit this file now, I want to keep it in a similar format to what's going on now. The actual bind service has been reconfiguring things in the background. I mean, I've since spun up a Windows computer and just out of curiosity to see what it's like, because I've noticed the Linux computers are very shall we say they're playing along properly. They're doing things as they should. Every time this computer gets restarted, an IP address gets released. Windows, no, nothing like that. It gets its IP address and it just holds onto it, whereas the Linux computer gets its IP address, then it releases it. It's much better at playing at the rules. But anyway, if I want to make a change, say for example I want to change the IP address of my DHCP server, obviously I've got to change the IP address entry here. If I want to create a new entry, yeah, I'll create a new line, fill in the details and so on. One thing I've got to bear in mind though is that serial number. That serial number is extremely important because this is a database. You must update this serial number by at least 1 every time you make a change. You'd have to do that in a normal environment. Up to now, it hasn't been that big of a deal for me because there's only one DNS server in my network. So it doesn't really matter if the serial number was out of sync or wasn't working because there's nothing else to compare against it with. As if I'd had an actual primary server and a backup server, then yes, it would have made more importance. But in this particular case, it really doesn't matter. There was only one DNS server and one file, and that's it. But now we've got a bind service. Every time it's going to make a change, it's going to change the serial number, and it has to keep itself in sync. So for that reason, if we want to make a change an existing entry, add a new line, whatever it is, always make sure that you update the serial number as well. And that'll keep things nicely in sync because, like I say, this is really a database system, so it's just something that you need to bear in mind. Anyway, I don't need to make a change as such, but I would also have to do the same sort of thing if we have a look at our reverse lookup zoom, for example, as well. So 172.16 is the one we've got. Just ignore the journal files. You'll never need to touch those, but this has been completely re-engineered compared to how I'd originally set it up, I've noticed. It's actually breaking the subnets out. It's got an origin of dot right at the top, and then it's actually broke it down into the individual subnets themselves, whereas I was just maintaining it based on the 172.16 supernet, if you will. This one's actually breaking it down into more specific details, but in any case, try and stick to the similar format that it's using. But again, always make sure that you update the serial number every time you make a change because it's a database. Once you've made your changes, whatever they are, we need to reinstate that actual service. So instead of being freeze, we want to use sudo rmdc thaw. So that's to basically thaw the database and let it come back into operation. So going forward, then what will happen is if the DHCP server tries to send updates, they'll get accepted. So that's just something to bear in mind on the maintenance. There's more things to factor in because it's not just you maintaining these databases, even the actual DNS server itself is. Now, as useful as DHCP and Dynamic DNS are, there are a couple of things I should point out, and that is that when it comes to your key infrastructure servers, so I'm talking about things like your DNS server, your DHCP server, hypervisors, firewalls, and so on, they should all have fixed IP addresses. So they should be IP addresses that are manually configured, which means you're going to have to put entries for those within the actual zone file yourself. You can't afford to have these sort of services relying on a DHCP server because if that breaks, everything goes down. This entire environment is based on a virtual environment. So if the hypervisors stopped working because the DHCP leases ran out, well, that's it. It's game over. You'd never be able to get back into them again. So there are key infrastructure servers that have to be on static IP addressing anyway. Everything else you can pretty much just leave it on DHCP. The only thing you have to bear in mind though is that, well, if you've got any firewalls and you've got very specific rules, and I'm talking about host rules where you've got a specific computer needs access to certain things, there's going to be a rule within the firewall only allowing access for a specific IP address typically. And that's going to be a bit of a problem, because if the DHCP server changes the IP address somewhere down the line, then that server is going to lose access to whatever it needed access to. So that's something you need to factor in. And there are actually different ways of dealing with it. It just depends on your environment. So for example, you could reserve an actual IP address on the DHCP server. So if I just jump over to this server here, we do sudo more dhcpd.conf. Scroll down here, for example, somewhere, there it is. So there was an example I'd set up where I'm actually reserving a specific IP address for a specific Mac. So this computer, every time it asks for an IP address, it'll always get that IP address. So that's one way you can do it. You can always guarantee that a computer always gets a specific IP address. That way it doesn't have any impact on the firewall because the IP address stays the same. Another way, which is better really, is if you've got more of a next generation firewall that actually supports rules that use DNS rather than IP addressing. It's because if a computer gets an IP address from the DHCP server, the DHCP server is now going to actually tell the DNS server. So when the firewall actually needs to do its check, it's going to go and reference back to the actual the DNS server. Now it will have its own little cache when it comes to doing resolution, but as long as that IP address hasn't changed too frequently, basically, then you should be okay. The DNS lookup will still work, and that server will still get access to whatever it needs to, regardless of what IP address was leased through DHCP. So that's a better way, because you can still maintain things through the actual DHCP server, but it's much easier if we can just get the actual firewall to use the FQDNs instead of IP addressing. So they're just a couple of things to bear in mind. But anyway, for me, this is going to make my life a whole lot easier. I don't have to go around looking around for IP addresses on a DHCP server to find out what IP address was leased out to a computer every time I spin it up. Now, just go and reference it by its FQDN. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.